We are on to section 7.3. We're dealing with number 28, and it's page 385. Very quickly, you're going to need to potentially use the table on Appendix A18. It's Table 5, or it's, and you can find it in the back of your book on the appendix region. Or if your book is reasonably new, you're going to have a Table 5 T distribution, and the appendix looks exactly the same. Real quick, it reads, an oceanographer claims, good trigger right there, we're looking for the word claims, that the mean dive duration of a North Atlantic right whale is 11.5 minutes. Now notice it says is in math is equals. So we have the null and the alternative established this way, and I've written the entire problem down, but I'm just going to have you focus right up here at the top. The null, the mean is 11.5. The alternative then is not 11.5, and because it's a not equals, we have a two-tailed test. Notice the word claim is on the null. It's attached to the null. That's going to help us in determining our final set of conclusions. Now, in the problem, it tells us as well that we have a random sample of 34 dive durations, and it has a mean of 12.2 minutes and a standard deviation of 2.2. Notice it doesn't say population standard deviation. It just says, after it says a random sample, and it lists what they get from the random sample. So you know that 2.2 is a sample standard deviation. That's the trigger that you know you need to use the t-test, not the z-test. You're told that you're running this test at alpha is equal to 0.10, which is right there. Now, to get the critical values, because it's a t distribution, it's a t-test, we need to use INVT. Not everybody's calculator has that, so hold on. If you don't have that, don't panic. We'll just use the table. If you're using INVT, the area, because it's a two-tailed test, and we're splitting the 0.10 in half. We're sharing that 0.10. The area is 0.05. The next piece with the t distribution is you have to have degrees of freedom. Your degrees of freedom is the sample size minus 1. So your sample size is 34. 34 minus 1 is 33. There's your degrees of freedom. I punch that into the graphing calculator, and I get negative 1.69 in a couple of decimals. On the table, if you will look, hold on. So first of all, I got to get this to line up right. So up at the top, you're going to say, oh, we've got a two-tail. So we're on this row right here, and we've got our two-tail with an alpha of 0.10. Then we travel down to 33 degrees of freedom. So you'll notice I've traveled all the way down to 1.69. Just a real quick comment. If you start getting down to the 70 and 80 for degrees of freedom, and you're not sure which to take, just go to the closer, and you'll be fine. The test, there is a way to extrapolate it. I'm not stressed by it, and generally you're not going to run into any issues that you'll have to worry about that. So you get from the table 1.694. On calculator it's 1.693 or something of that nature. Now, your next piece is you're going to be running a t-test. So you're going to have that stats, you're going to have the test, and again it's going to start off by listing mu naught. Well, that's your 11.5. Then you're going to have your, and I'm right here, then you're going to have, I believe, the X bar. I might have this out of order. Then you'll have your N, and then you'll have your sample standard deviation. That's what mine lists it as, but that might be flip-flopped. So just make sure you put in the right stuff in the right spot. And then this is the not equals. So you're going to highlight the not equals. You should get a t-score of 1.855 and a p-value of 0.07. Now, 1.855, remember our critical values were 1.69. Well, this is a negative 1.69 and this is a positive 1.69. And the 1.855 is landing out in the tail. Now there's this goofy thing with two-tailed tests in that you write it on the right side and you put it on the left side. So we do the positive, we do the negative, and the p-value is actually from both of those test statistics out into the tail. So your p is equal to 0.07. It's still smaller than your alpha. So you are going to reject the null at alpha's 0.10. Now, if we're rejecting the null, travel up to the null, and we are going to put a line through it. And the word claim ends up getting a line through it as well. And so there is insufficient evidence to support the claim, and then you restate the claim. Again, in the back of the book, at times it'll do some tweaky stuff with the wording of it, like it's not going to be the case that we're not going to reject the null and so forth. I actually talked to some of my professors when I was a young student, and I said, can't we just simplify this? And they're like, yeah, just word it the way you would as a human being would. You're not going to play the word game. Other than that, I'm going to quick do one from 7.4, and hopefully this helps you guys. I'll talk to you later. Bye.